spread of the data. If you look at these scores, set A has the numbers 1, 2, 2, 3. Set B has the numbers 1, 5, 7, 9. Which set is more spread out, and how do you know? Which one's more spread out? B. And you can sort of tell because the scores are more further apart from each other, isn't it? So, and the next question is, how about the following? 2, 5, 8, and this one, 2, 4, 4, 5, 6, 6, 8. Which one's more spread out? Maybe C, maybe D, we don't know. Now let's look at the range. If I look at the range for set B, that will be 9 minus 1 equal to 8. Whereas the range for the first one is 3 minus 1 equal to 2. So clearly the range gives us a way of measuring the spread, because the smaller the range, the smaller the spread. So, however, for the next one, if you calculate the range, they have the same range, isn't it? But how do you compare their spreadness? How spread out they are? They're the same, right? So we need to have a way of measuring the spread. Let's try to do some experiment with numbers. So what we do is we're going to calculate the mean of set B. So we're going to look at, we're going to calculate the spread of this data. Let's calculate the mean. So we're going to add the numbers together. So we'll do 1 plus 4 plus 5 plus 9. No, 1579. 1579. 1579. Divide by 4, what do you get? 5 over 9? No. 5.5. So 5.5, right? So 5.5, so that's 10. 22. 22 divided by 4 is, yeah, 5.5. Let's start measure its spread by calculating each of the scores difference from the mean. Okay, to work out the spread is to work out how far they are from the mean. Okay, mean is like the center of the data, the deviation. So we're going to subtract 1 by the mean, the 5 from the mean, and then 7 from the mean, and 9 from the mean. Okay, let's do that. So let's see what answers we get. 5. So the first one we get negative, so you get negative 4.5. Negative 4.5. The next one is negative 0.5. Next one is 1.5. Next one is 3.5. Yeah? Okay. Once we do that, what you need to do is to add the difference together. Let's see what you get. Add the difference. So to work out the spread, it should be related to all the difference. So if we add the difference, let's see what we get. So we get 4.5. Oh no, that's negative. So negative 4.5 minus 0.5 plus 1.5 plus 3.5. Yeah, equals 0. So they always add up to 0, the deviation, because you have the negative, which is less than the mean. You have numbers above the mean. So whenever you add all the deviation, you always get 0. So that's not a good measure of spread when you add up the deviation. So what we do is we try to get rid of the negative by squaring. So let's square each of these numbers. So we're going to square the negative 4.5, and then we're going to square the 0.5, and then we're going to square the 1.5. Okay, square each of these. Work out the square of its deviation using a calculator as well. So 4.5 square, you get 20.25. That. Continuing, 0.5 square is 0.25, and 1.5 is 2.25. 3.5 will be 12.25. Yeah. Alright, so if you add them up, let's see what we get. Get 20.25 plus 0.25. Actually, it's easy now, because all these add up to 1. That's 22, 22, 32, 34, 35. So you get 35. Okay, good, 35. So that's the sum of the deviation square, which you get a very large number compared to these numbers here. So how do I make it smaller? we should, actually I wrote it here, that's equal to 35. Now, how can we make this number smaller? What we do is we divide by the number of scores, so we average it. So we do 1 over n. N stands for the number of scores, so you get 35 divided by 4. And then we're going to, I'll use a calculator. So 35 divided by 4, we get 8.75. But still it's pretty big. So what we do is, because we square something, we should square root it. Let's square root it, that will make the number even smaller. Alright, 2.96 to 2 decimal place. Okay, so that's the spread. The spread of the data is 2.96. Okay, correct to 2 decimal place. Okay, and the symbol for this spread is called the sigma, and sigma stands for standard deviation. So it looks like this, sigma. So it's like an O with a little tail. Okay, that's called sigma. Okay, sigma. Okay, and you can do all of this on a calculator. The calculator have a formula for this standard deviation. So this is called the standard deviation. Standard deviation. So please get a calculator out. Your first step is to press mode. Press mode first. It's written here. Press 2. And then 1. One variable. Does that make sense? Mode 2, 1. Written here. Mode 2, 1. Let me highlight it for you if you can't see it. Oops. Mode 2, 1. Okay, we just did that. Okay, after we do this, we're going to enter the scores. Hopefully you remember from last year how we entered the scores. The scores are 1, 5, 7, 9. So you go 1 equal, 5 equal, 7 equal, and 9 equal. Right? You get 4 numbers. Enter the scores. So you go 1 equal, 5 equal, 7 equal, 9 equal. And then after that, the next instruction is press AC. Clear the screen. AC, clear it. It's already entered into the system. Now, the first step, you can actually work out the mean. To work out the mean, you go Shift 1, and then press 4. Now, mean is 2, so 3 is the standard deviation. So if you press 2, it should give you 5.5 as expected. To get the standard deviation, Shift 1, 4, and then 3. This is standard deviation. See the sigma? Sigma x. So press 3 equal 2.96 as we got before, right? It's the same thing. So the calculator does all this complicated formula on the calculator. That's called the standard deviation. Does that make sense? All right. Yep. Good question. Maybe, yeah, I think you should know the formula. I think it's in the syllabus. Yeah, but maybe for a few numbers, not for like 10 numbers. That would be too long. All right? Okay. All right, next. Say again. Sigma. Yeah, that's the symbol for standard deviation. All right. Next page. All right, so now I'm going to present you the summary. So the standard deviation is a number that describes how far data values deviate from the mean. The symbol for standard deviation is sigma. These are the steps that your calculator uses. Find the mean, find the difference between each value and the mean called the deviation, square the deviation, sum the square of deviation, divide by n, and square root, which is this complicated formula here. Okay? Okay, so in a data set in which all the data values are equal, the standard deviation is 0. There's no spread if all the scores are the same. If the data are concentrated about the mean, then the standard deviation is relatively small. If the data are spread out from the mean, then the standard deviation is relatively large. Calculating the standard deviation step by step. So I want to calculate the mean and the standard deviation for this small data set, correct to 1 decimal place. Yeah, maybe use the calculator because the formula can be too long. Let's use the calculator. So what you do is you go Shift Mode, not Shift Mode, sorry, was Mode 2, 1, enter the scores, 2 equal 4 equal, 5 equal, 8 equal, 9 equal. Get it? 5 scores. Press AC, shift store, not shift store, oops. Shift 1, 4, okay? And you want the mean, press 2, the mean is 5.6. And the standard deviation, you should get shift 1, 4, 3 equal 2.58 or 2.6 correct to 1 decimal place. Get the idea? Or you can use the formula. So if you use the formula, let's try to use the formula. So the sigma equals to the square root of, so what you do is you just go 2 minus the mean, and then plus 4 minus the mean. Let's make it a bit bigger. Let's try again. Okay. So rub this off. So 2 minus the mean. 2 minus the mean, 5.6 square plus, what's the next score? 4 minus the mean plus, oh, wrote the wrong thing. 4 minus the mean plus 5 minus the mean square plus 8 minus the mean plus 9 minus the mean. And then all of these divide by how many scores there are, which is 5 numbers. Alright, use your calculator. Let's try to do that on a calculator. So let's get rid of the statistics mode. Mode, press 1. That will get rid of the statistics mode. Press square root. Press the fraction. You go bracket 2 minus 5.6 square, close bracket, plus 4, bracket 4 minus 5.6 square, close bracket, square, plus bracket 5 minus 5.6 close bracket square, plus 8 minus 5.6 close bracket square, and then one more, 9 minus 5.6 square, close bracket, square, and over how many scores? 5 scores, right? 5 equal. C gives you the same answer. Press mode, press 1. Mode 1 to get out certificate. D is there permanently. It means degree mode. Does it have stat on top? Does it still have stat? Okay, so to get rid of this, what you need to do is press shift mode. I think you have to press 1. Shift mode 1. Math.io. Does that fix it? Yep, okay, good. Alright, any question? Okay, now you know how standard deviation works, the formula, and how to do it on a calculator. The next step is to do some problem solving questions. Next page. Okay, let's start with this. Example 2. This back and to back stem and lead plot shows the distribution distances that 17 people in Darwin and Sydney travel to work. The means and standard deviation are given below. So it looks like the average for Sydney is higher than the average for the Darwin, and the spread is higher than Darwin, right? That will tell us a bit about the information how people live in Darwin and Sydney. So consider the position and spread of the data, then answer the following question. By looking at the stem and lead plot, suggest why Darwin's mean is less than Sydney. Okay, so who can suggest why? The travel distance is, the average travel distance is lower than Sydney. Maybe Sydney, some people live very far away from work. So it's more, a lot of people live far away from work. So maybe Sydney is a bigger city. Is a bigger city. So most likely you can live further away from city. Maximum score for Darwin is 35. Sydney's mean is affected by several values larger than 35. Okay, I look at the 70 plot. Okay, so what you do is, actually we're not supposed to write this. That may come later on. Okay, so but anyway, if you wrote it, that's okay. There's enough space. So you should say the maximum score for Darwin is 35. So that's the maximum score. And because for Sydney to have a higher average, they have more score above 35. And Sydney's mean is affected by several values larger than 35. That's the reason. Okay, so that's the reason why the mean is higher. Then we're now going to explain why is Sydney's standard deviation larger than that of Darwin. Okay, the data for Sydney are more spread out from the mean. Yeah, so as you can see, the standard deviation for Sydney is higher because Sydney seems to be more spread out than Darwin. So it's more spread out from the mean. So the mean for Sydney is 27. The mean for Darwin is 19. Yeah, so the score are more concentrated around the mean for Darwin than Sydney. That's why Sydney has a higher standard deviation. So let's write this down. So the data for Sydney, the data for Sydney are more spread out from the mean, and Darwin scores are more closely clustered near its mean. Okay, so that's the explanation. Okay, good. And finally, give us practical reason why the difference in center and the spread for the data for Darwin and Sydney. So Sydney is a larger city and more spread out, so people have to travel further to get to work. That's the explanation. Sydney is a larger city and more spread out. So people have to travel further to get to work. Alright, that's done. That's standard deviation. So most of the question you need to know how to use the calculator to calculate the standard deviation. Some question may ask you to use the formula to calculate. Make sure you practice these. These will all be examined in your next topic test. Okay, good. Alright, start now. You can start the work.